Okay, Atif, but we have already started the continuity, okay? So please try to complete this week only. Next is Noma. Noma is not in the class. Nabil Khan. Nabil, you have not shared a single assignment with me.
Yes, sir. I have completed 5 assignments. I'll send
Fine.
it.
Okay. So you have my number, Nabil?
Yes, sir.
You have my number?
No, sir.
Okay, then please note down this. Okay. And please share the homework whenever you will complete any assignment um, because after every 15 days, we will share the status with your parents. Okay. Next, who is there? Atif. Sorry, Nabil Ahmed. Nabil, very good. You have already completed 7 assignments, and I guess 8 you are still doing.
So the eighth one, I have some doubts. So I think I sent you what I completed.
Yes, you have shared, but I guess there are many questions.
Yes, sir.
in-
I have some doubts now.
Yep. Okay. Okay. So you have a doubt and rest of the questions.
Yes, sir.
Okay. Great. So we will discuss your doubts after the class. Okay. Okay, so in the last class, we have already done the limits. So anyone have a doubt in limits? If no, then we will start the limit. Sorry, continuity.
So log E is always equal to 1.
Log E, if the base is E, then yes, it is equal to 1. Okay, log
Okay.
E to the base E. So concept is very simple. As you all know that if you have 10 cube is equal to 1000. Okay, then log 1000 to the base 10 is equal to 3. So we will understood in this way that what should be the power of this 10 so that we will get 1000. So that is 3. So if I will say to you that what is log 10 log 10, so you will try to find out a value, the power of this so that you will get a 10. So that is 1. Similarly, we have a log E to the base E. Again, what should be the power of E so that you will get this E? This will be 1. Okay, Nabil?
Yes, sir. So because in some questions, just log E is there and final answer comes 1.
Yes. So what happened if no base is given? Then that means it's a natural log. Okay. If no base is given, so that means it's a base C.
Yes,
Okay.
sir. Yes, sir.
Okay. Okay. So Darshan, you have just joined. So I've already shared the homework status with everyone. Okay. And I do not receive any assignment from your side, Darshan. Do you have completed this? Darshan, do you have completed the assignments? You can reply me on the chat. Which phone number? Okay, I will again send you the number. Okay. How many assignments you have completed, Darshan? One to four. Then please share the assignments with me. Okay. And everyone, whenever you're sharing the homework with me, then on the first page, please write your name. Okay. Okay. Then we have already done the limits. Just give me a minute. We will. Okay. Any doubt in limits? Anyone have a problem in limits?
No, sir.
In last class, we have done a LHL and RHL method. Okay. So we will again discuss that. Suppose we have this question, fx is equal to 2 minus x, okay, when x is greater than equal to 0. And we have 2 plus x when x is less than 0. So the question is, check whether the limits, check whether the limits. We're still discussing limits only. Okay, after this, we will start the continuity. Check whether the limits, check whether limit x tends to 0 fx exist or not. Okay, exist or not. Okay. So Noma, you were absent in the last class, so please check here. When we will say that the limit exists, when the left hand limit and right hand limit are equal. Okay, left hand limit means LHL. LHL represent left hand limit. So first of all, we will find left hand limit LHL at x is equal to 0. So this is limit x tends to 0 minus fx. Okay. Now for this function Noma, we have two values. When the x is greater than equal to 0, then the value is 2 minus x. And when the x is less than 0, we have this value 2 plus x. So for this LHL, Noma, can you tell me which value we will choose, the first or second?
Second.
Second one. Good. So we will write like this, limit x tends to 0 minus, and fx is what? 2 plus x. Okay. Now please remember this step that you need to write like this, put x is equal to 0 minus h. If you're finding the LHL, then please write x is equal to 0 minus h. So what you will write here, limit 2 plus, in place of x, you will write 0 minus h. Okay. And in the bracket, please write when x approaches to, please write when x approaches to 0 minus h approaches to 0. Okay. When x approaches to 0 minus h approaches to 0. So here, right, h tends to 0. So this you have limit h tends to 0. This is 2 minus h. Now put this limit 2 minus 0. So you will get a 2. So that means left hand limit is 2. Okay. Next. Next is RHL. RHL at x is equal to h is what? H is a value which is very close to 1. Tends to 0. H is a value which is very close to 0. Okay. RHL at x is equal to 0. So here you will get what? Limit. For RHL, you need to represent this like 0 plus fx. Okay. So Noma, for RHL, which function we will choose?
2 minus x.
2 minus x. Okay. So here you will get limit x tends to 0 plus, and this is 2 minus, sorry. In the last, okay. So this is 2 minus x. Again, you need to write, put x is equal to, for RHL, you need to put 0 plus h. Okay. And bracket always write like this, when x approaches to 0 plus h approaches to, h will always tends to 0. So here you need to write like this, limit 2 minus, in place of x, you will write 0 plus h. In place, here you will get h tends to 0. So this is limit h tends to 0, 2 minus h. Now put this value. So you will get a 2 minus 0, which will finally give you 2. So here we can see that limit x tends to 0 minus fx is equal to limit x tends to 0 plus fx is equal to 2. Hence, limit x tends to 0 fx is equal to 2. Okay, so if you are getting LHL is equal to RHL, then that means limit exists, and the value of the limit is the LHL or RHL value. In case LHL and RHL are not equal, then we will say that the limit do not exist. Okay, so is it clear, Noma?
Yes, sir.
Okay, very good. So please note down this, Noma, confirm me, then we will try one more question. So Noma, I'm not sure that what topics you have covered in limits. In last class, we have discussed factorization method, direct method, rationalization method. So
Sir,
do you have,
actually, sir, I will revise it from my 11th class notes.
okay. Please let me know once it is completed.
So please show the previous slide.
Yeah, okay.
Done.
Okay, good. So all of you, please remember, if you have an inequality type of questions and you need to find the value of the limit, then always use RHL and RHL concept. Second, if you have a modulus type of questions, okay, in modulus questions, always use LHL and RHL because here we need to define the modulus. So we will check a question in continuity and use the concept of this limit, okay. So just give me 2 minutes. I will just revise the topic which we have done in last class. So methods to solve the limits, methods to solve the limits. Okay, so first is direct method. Okay, Noma, in direct method, what we will do, we will just put the limits directly. For example, x squared plus 2, limit x tends to 1. Just put this limit, you will get a 3. Okay, if you can put any, if you can put the limit in the function and you're getting a real number, then it is fine. That is the final answer. Second, we have the rationalization method. Okay, what we do in the rationalization method, for example, if you have this limit x squared minus 3x.
Sir, factorization, right? Second one.
Sorry. Second is factorization.
Yeah.
Thank you. So second is factorization method. Okay. Suppose we have this function, limit x tends to 1. If you will directly put this limit here, then what you will get a 0 by 0. So if you're getting a 0 by 0 form, then it is not possible for you to use the direct method. Then we will proceed to the next method, that is factorization. We will factorize this. Okay. Next is limit x tends to 1. Factorize this one, x squared minus 2 minus 3x plus 2 by x minus 1. So here you will get limit x tends to 1, x minus 2. Okay. Sorry. So here minus 2x and minus x. So take x common, x minus 2, take minus 1 common, x minus 2 by x minus 1 is equal to limit x tends to 1, x minus 1, x minus 2 by x minus 1. Cancel out this x minus 1. Then you will get a limit x tends to 1, x minus 2. Okay, now you can put the limit 1 minus 2 is equal to minus 1. Okay, Noma? Is it fine?
Yes, sir.
Okay, so shall we move to next?
Yes, sir.
Okay, now the third is rationalization method. Okay, what we do in rationalization method, suppose you have a question like this, limit x tends to 1, root x minus 1 by x minus 1. Okay, so you have a root here. We will check the direct substitution method. Here we are getting 0 by 0, so direct is not possible. Factorization is not possible. So what we will do, we will use the rationalization method. So you need to multiply and divide this with, change its sign, root x plus 1 into root x plus 1. Okay. So in the numerator, apply the formula a square minus b square minus 1 square by x minus 1 into root x plus 1. In the numerator, what you will get, limit x tends to 1. Here you will get x minus 1 by x minus 1 into root x plus 1. Limit x tends to 1 by under root x plus 1. So this is equal to 1 by 1 plus 1. 1 by 2. Okay, so this is the rationalization method. Noma, shall we move to next?
Yes, sir.
Okay. Fourth is by using standard results. Standard results. Okay. So first, I hope you remember this. Limit x tends to a, x to the power n minus a to the power n by x minus a. This is equal to NaN minus 1. Okay. So we will see in continuity if we will get a question like this, then we will use this formula. Some more formulas we have like this: limit x tends to 0, sin x by x is equal to 1. Third, limit x tends to 0, tan x by x is equal to 1. So fourth is limit x tends to 0, cos x is equal to 1. And fifth is limits x tends to 0, sin x is equal to 0. Okay. So I've just given the summary of the limits. Please, Noma, note down this and confirming. Now we will start the continuity. Okay. Is it done, Noma?
Yes, sir. Done.
Okay, okay. So just give me a minute. Okay, and tomorrow again you have a test of differentiation. Okay. Okay, so next chapter is continuity. Okay. First of all, we will check that what is the definition of continuity. Continuity is what in many functions many functions have the property that they can trace a graph with a pencil without lifting the pencil from the paper surface. These types of functions are called continuous functions. Okay. A function is continuous at a particular point if there is no break in its graph at that point. So we will understand this concept of functions in a very simple language. When we will say that a graph is continuous or a function is continuous, if we can draw the graph without lifting a pen or pencil. For example, if I can draw this graph without lifting my pen, then I will say that this function is continuous function. Okay, this is a definition of function in a very simple language. When we will say that a function is continuous, if we can draw its graph without lifting the pen. Okay, for example, if I'm going to draw this graph, then please check here, I will draw like this, then I will pick my pen and I will draw like this. So at this place, I have to pick my pen to draw the complete graph. That's why this is not continuous. Okay, so if you can draw this graph without lifting the pencil or pen, then you will say that this function is continuous. If you have to lift your pen to draw this graph, then we will say that this function is not continuous. Okay, and we can also say that a particular a function is continuous at a particular point if there is no break. Okay, a function is continuous at a particular point if there is no break in the graph at its point. This is clear to everyone. All of you, please raise your hand. This is clear?
Yes, sir.
Yes,
Okay.
sir, it's clear.
Okay, good. Nabil
Yes, sir.
Khan. Okay, Nabil, Atif, good. Darshan, is it clear? Okay, great. Now, please note down this, then we will discuss the next point. Okay, so please note down this, then raise your hand. Okay, Darshan, good. Okay, Atif. Okay, Nabil Khan. Okay, Noba. Nabil, is it done? Shall we start next? Nabil.
Yes, sir.
Okay. So Nabil, okay, good. Next one. Next is continuity at a point. So we have checked that what is the meaning of continuity when we will say that a function is continuous. Okay. Now in this topic, we will check that what is the condition for a continuity. When we will say that the function is continuous, so the condition is if we have a function fx, we need to check that this function fx is continuous at x is equal to a or not. If you have to check that this function fx is continuous at this point or not, so what we will do, we will find the limits x tends to a. Okay, we have to check at this point. So we will find limit x tends to a. Please don't note this. I will give you the time. We will find this limit x tends to a for this function fx if this is equal to fa. If this is equal to fa, then we will say that our function is continuous at this point. If you are finding the limit of the function at that point, and if that limit is equal to fa, then we will say that the function is continuous at that point. Okay, so we will try to understand this concept from the graph. Okay, so the same thing I have written here. A function is said to be continuous at a point x is equal to a of its domain. Definitely this point should be in the domain of the function. So function is said to be continuous at a point x is equal to a if the same thing, limit fx is equal to f. Please note down this, raise your hands, then we will try to understand this from graph. Okay, Nabil, good. Atif, Darshan, Nabil, Khan, Noma. Okay, Atif, good. Okay, Noba, Nabil Khan. Darshan, is it done? Darshan, is it done? Okay, great. Okay, Darshan, no issue. Then you can reply me on the chat box. Okay. Next. Next is a function fx fails to be continuous at x is equal to a for any of the following reasons. So in the previous statement, we have checked that what is the condition when the function is continuous at a particular point. Okay, so the condition is limit x tends to a. Condition is limit x tends to a fx is equal to f. Okay, this is not a tough topic. Okay, so but if anyone have a doubt, then please let me know. So this is our condition. This is a condition when the function is continuous. Now, what is the condition that the function is not continuous at the point? So the first point is limit exists, but it is not equal to fn. Okay, we will check with the graph. While we were doing the limits, while we were revising the limits, I already told you that limit exists at x is equal to a is not connected with fn. The function at that point exists or not, that will not affect the limits. I'm talking about the concept of limits. Now we will check this statement from the continuity point of view. Suppose we have this graph. Okay, we have this graph. Let this point. Okay, there's a space here. There's a break here. So this is x is equal to this is 3. There's x. Okay, this is 3. Let this be 4. Okay, and graph is like this. This is your graph. Then there is a break, but this point. Suppose I'm taking this point. This point is a part of a graph, and we can say suppose this point is here on the y-axis. This is 3. Then I will remove this. I will write 5 here. Okay, so graph is like this, that this one break, and this point is also a part of a graph. Okay, now who can tell me? Darshan, this is your graph, this is your function fx. Then Darshan, can you tell me what is the value of f5? Uh, very good, very good. So I hope this is clear to everyone that the value of f5 is 3. Okay, this is a point we can see here that this value is 3. So f5 value is 3. Anyone have a doubt in this? F5 is equal to 3. This is clear to everyone.
So why is it not 4?
Why it is not 4? Very good. Because this is your graph and we can see there's a space here. There's nothing here. Okay. There's a space here and this point is also part of a graph. So at this point, what is the value we have on the y-axis? That is 3. That's why the value is 3 and not 4. You will never get a 4 here because nothing is here. There's a break. There's a break here. Nothing is here. Okay. Now, who can tell me? Nabil Ahmed. Can you tell me what is the limit x tends to 5 fx? Nabil Ahmed.
3, sir.
3. Atif, what's the value limit x tends to 5? 3. Oh. Who is next? Darshan. Darshan, what is the value limit x tends to 5? Very good, Noma. This is correct.
So it will be less.
Sorry, Noma, please again check the answer. Okay, this is not correct. Sorry. Yes, Nabil Khan. What's the answer? Limit x tends to 5 fx?
Less than 3.
Less than 3. Okay. So we will again use the concept of LHL and RHL. If we will approach this value from the right side, if we are approaching this value, then check this graph. This graph is approaching to what value? I'm saying approaching to, okay? I'm not saying exact value. I'm saying if we will move from the right side to this point 5, then where this graph is approaching?
4.
4. So we can say that the RHL is 4. Check LHL. From the left side, if we are approaching this value 5, if we are approaching, so what is the value? The graph is approaching to what value?
4.
Again 4. So LHL is also equal to 4. So that means limit x tends to a, limit x tends to a fx is equal to 4. While we have find out, sorry, why a? Limit x tends to 5 is equal to 4. And what is the value of f5? It is equal to 3. So here we can see that limit exists, fine. Function exists at this point 5, fine. But the limit and this value is not equal. These two are different. These two are not equal. What is the condition for us for the function to be continuous? This is the condition. Limit x tends to a should be equal to fa. So we have seen first case where limit exists, but it is not equal to fa. We can see here these two are different. Now we will see here, can you draw this graph without lifting your pen? Can you draw this complete graph without lifting your pen?
No, sir.
No, it is not possible. If you're drawing this, then at this point, you need to lift your pen. So here we can say that this function is not continuous. And we have seen the first condition. This is your first condition. In this condition, the limit and the fa are not equal. That's why your function is not continuous. We have checked this from the graph. Okay. So what's the first condition? When your graph will not be continuous, when limit exists, fa exists, but these two are not equal. This is fine. Nabil, Atif, Darshan, Nabil Khan, and Oma,
Yes,
please raise your hands if this is clear.
Yes, sir.
Okay, very good. Okay, Nabil. Darshan, Nabil Khan, is it clear?
Yes, sir.
Okay, very good. Then please note down this graph, okay? And future, when you will revise the same concept, then this graph will help you. Okay, please note down this graph. I will give you just 30 seconds for just 1 minute for this. Okay, then please raise your hands. We will see the second condition. Everyone, please raise your hands once it is done. Okay, so I hope everyone has completed this. Okay, so we are going to check the next one. Anyone is left? Shall I erase this graph? Please let me know if anyone is left. Otherwise, I'm just going to erase this. Okay, so we will check the second point. Okay. What is the condition for the function to be continuous? This is the condition. Limit x tends to a, fx is equal to f. Okay. If a function satisfies this condition, then it is continuous at that point. Now we are discussing in what cases the function can't be continuous. So what is the different scenario we have? First is we are saying these two are equal. Okay. First scenario is when these two exist, but these two are not equal. What can be the second scenario? The limit do not exist. Okay. Okay. So second scenario is limit does not exist. What was the first condition? Limit exists, fa exists, but these two are not equal. What is the second condition? Limit does not exist. Okay. If you are trying to find the limits and LHL and RHL not equal, you know what's the condition when the limit does not exist. So if a limit does not exist, then the function will not be continuous. So we will check this with a graph. So we have this. Okay. This is the point, and suppose here we have the point 5. Okay. And let this be 4. Exactly at this point, there is no break. You have a point here. Okay, no break here. Then if we have a break in a graph, then we represent like this. Follow. Okay, there's a graph like this. Okay, if there's a break, then we normally draw hollows so that everyone can understood that here we don't have any point. Suppose here we have a 6. Okay. Now the next question is from Nabil Khan. Okay, Nabil, can you tell me what is the value of F5? Nabil Khan, what is the value
Yes,
of
sir.
F? Yes. What's the value of F5?
6.
Why 6? Please check here. At this point, x is equal to 5. Go here. Here,
Okay, 4.
4. Very good. So F5 is 4. I hope everyone understood this. Okay. Now we will find the LHL. How we represent the LHL? X tends to 5 minus fx. How can we find this LHL? We take this graph and we move from the left side and we approach this 0.5. So we will check if we are going close to this 0.5 where this graph is approaching. This is approaching the value 4. Here we have a 4. Now we will find the RHL, limit x tends to 5 plus fx. So how can we find the RHL? We will go here and we will approach this 5 from the right side. So we can see here we have a graph and we will go like this. This graph is approaching what value? This is approaching 6. Okay, so how can you find from the graph LHL and RHL? Just put your one step here and try to move towards this 5. Okay, and in this way check where your function is approaching. It is approaching 6. So here we can see the limits LHL and RHL are not equal. It is 4, it is 6. That's why the limit does not exist. In the second case, limit does not exist. Now the next question is from Noma. Noma, now can you draw this graph without lifting your pen?
No, sir.
No, so that's why this is not continuous. You can see here, how can you draw this graph? Go like this, then lift your pen, then draw this part. So here also we can see that the function is not continuous at this point, and this is the second condition, that limit does not exist. What was the first condition? Limit exists, FA exists, but these two are not equal. What is the second condition? Limit does not exist. That's why the function will not be continuous. So please note down this and raise your hands. Once it is done, then we will check the last condition. Okay, Nabil, very good. Okay, Noma, good. Atif, Darshan, and Nabil Khan, please confirm if it is done. Okay, Darshan, very good. Atif and Nabil, is it done? Atif and Nabil Khan, is it done? Okay, Nabil, good. Atif, is it done? Atif, is it done? Not sure, Atif, why you're not replying. So I'm going to erase this, Atif. Okay. If you miss anything, please let me know. Okay, so the next one is third. Third is in the second, we have the limit does not exist. We will check the third one where FA do not exist. Okay. Third is F is not defined at x is equal to A. That means FA does not exist. Okay. So we will draw the graph. So we have a graph like this. We have a break here. Okay. Here we don't have any, we do not have anything. Here we have 5. So you can see here we do not have any point, and let this be 4. So if you will move from LHL or from RHL, you will get the same value. So we can say limit x tends to 5, fx is equal to 4. Okay. Now, F5 do not exist. You can see here there is a break. No point is there. So we will say F5 do not exist. Do not exist. So the next question is from Nabil Khan. Nabil, can you draw this graph without lifting your pen?
No, sir.
No. So that's why this function is not continuous. Okay. So we have checked that what is the condition for continuity. What is the condition when we will say that a function is continuous at a point? This is the condition that limit at that point should be equal to f. Okay. We will draw the graph of this one also. Suppose, for example, you have this, you have this one. This is your 0.5. Here you can see here you have a 4. So if you will find the limit here, limit should be equal to 5. Limit x tends to 5 fx. This is equal to 4. If you will find the value of f5, this is also equal to 4. So we can see here at this point, the limit exists. FA exists and these two are equal. That's why we can draw this function, draw this graph without lifting up pen. That's why this function is continuous. So this is the condition for continuity at a particular point. If we need to check that the function is continuous at any point or not, limit should be equal to FA. Now, what are the different conditions when the function is not continuous? We have these three conditions. Okay. And the first one, limit exists, FA exists, but these two are not equal. And second condition, limit does not exist. And the third condition, FA do not exist. So we have seen in these three conditions that there is a break in the graph. So all of you, please note down this, the third graph, confirm me, then we will try to solve some questions. Okay, Nabil, very good. So Atif, Darshan, Nabil Khan, Noma, please confirm if it is done. Okay, Noma, very good. Atif, okay, good. Nabil, okay, Atif, very good. Darshan, is it done? Shall we start next? Darshan, is it done? Shall we start next? Okay, great. Okay, so graph we have already done. Next. Next we have this question. Show that the function f(x) given by this. This is your complete function. Write it like this. This is your function. When x is not equal to 0, this function, this. So we need to check, show that this function, sorry. Show that the function given by f(x) is equal to this. I will complete this, is continuous at x is equal to 0. Okay. So the complete question is, show that the function f(x) given by this one is continuous at x is equal to 0. So we need to show this. Now, first of all, I need the formula. Who can tell me? Darshan. Darshan, what is the formula to check that the function is continuous or not? Darshan, what is the formula? You can unmute yourself, Darshan, and tell me the formula. The formula to check that the function is continuous or not at a particular point. We have just done that formula. Please turn your page. Nabil, f(x) is equal to fa? No, Nabil, not correct. Okay, please check here, all of you. Yeah, this one. Okay, what is the condition when the function is continuous? Limit extends to a, f(x) is equal to fa. So if in exam they will ask you to check that the function is continuous or not, just check this formula, that limit x tends to a. Okay, so the for the function to be continuous at x is equal to a, limit x tends to a, f(x) should be equal to fa. Okay, we have already discussed this condition when we will say that the function is continuous at any point, limit should be equal to fa. Okay, now the next, okay, Nabil, I guess you have already done. Good. So the next question is from again Darshan. Darshan, in this question, can you tell me that what is the value can you tell me what is f0, Darshan? Very good. So we will check here, f(x) is equal to 2 at x is equal to 0. If x is equal to 0, then fx is equal to 2. So we can say f0 is equal to 2. I hope this is clear to everyone. If you will analyze this, if x is not equal to 0, then we need to use this function. If x is equal to 0, we need to use 2. So fx is equal to 2 at x is equal to 0. That's why we can say f0 is equal to 2. Now next, limit x tends to 0, fx. Okay, Noma. Noma, can you tell me which function we will use for the limit? First or second? Okay, Atif, good.
Second.
Second. Okay, so the next question is from Nabil Khan. Nabil Khan, which function we will choose from the first function or second function for the limit? If we need to calculate this limit, which function we will choose, first or second?
Second.
Second, very good. And Nabil, can you tell me why we will? Oh, okay, sorry, second. No, not correct. Next is Darshan. Darshan, can you tell me which function we will choose and why? If we need to find the limit x tends to 0, we have two functions. Okay, so Darshan, I'm saying that if we need to find this limit x tends to 0, which function we will choose? If we need to find this limit x tends to 0, we have here two functions. So from these two, which function we will choose? Darshan? Okay, second. No. Nabil Ahmed. Nabil Ahmed, can you tell me which function we will choose?
Second answer.
Second one. Oh. Atif, you heard the last one. Please tell me the correct answer. Which function we will choose and why?
So can you repeat the question?
Yeah, the question is we have two functions here. Okay, fx is equal to this when x is not equal to 0. X is equal to 0 when x is equal to 0, we have fx is equal to 2. So when we are trying to find out the limit, then which function we will choose, first or second? And also the reason.
Second.
Second. Oh. All are incorrect. Please check here. We are finding the limits. So what is the meaning of limits? We have already discussed from the graph some days back that what is mean by this limit? This limit is, suppose you have this function. Okay, let this be a. This is your fx. Then it's mean if we are saying that limit x tends to a fx, it's mean if we are approaching this value, x is not equal to a, we are saying if x is approaching this value, then fx will approach to which value? What is the meaning of this complete symbol? This means if x is approaching to value a, if x is approaching to value a, then fx will approach to what value? So x tends to a means x is not equal to a. This means x is approaching to this value. It is very, very close to a, but it is not equal to a. Then we have different methods to solve. And in it, we have the first method where we will directly put the limits. So that is a method. But what does this mean? X tends to a. This means x is approaching to a, x is going towards to a. Okay, I'm again saying x is going towards to a. So that means x is not equal to a. It is going towards to. So I can say that x is not equal to a. It is approaching to a. Okay, here we are saying that limit x tends to 0 means x is going towards to 0. X is not equal to 0. It is going towards to 0. So that's why if we need to calculate the limits and we have these two values, then we will select the first one. X is not equal to 0. X is going towards to 0. Okay, so we will select the first function, which is sin x by x plus cos x. Okay, so please remember limit does not means x is equal to 0 or x is equal to a. Limit means you are approaching to that value. You are very, very close to that value, but that is not equal. So please remember x is not equal to 0 here. That's why we will use the first function. Is it clear now? Nabil, Atif, Darshan, Nabil Khan, Noma. Is it clear now? Okay. Nabil Ahmed. Okay, Darshan, good. Nabil Ahmed, Nabil Khan, Noma.
Yes, sir.
Okay, good. Okay, Nabil Khan. Nabil Ahmed, is it clear? No response. Any doubt, Nabil? Nabil Ahmed, any doubt here? Sorry, Nabil, will you please raise your hand if it is clear to you? Okay, great. Now we will solve this limit. We have two expression here. So we will write limit x tends to 0 sin x by x plus limit x tends to 0 cos x. Okay. Next question is from Nabil Khan. Nabil Khan, what is the value of this limit x tends to 0 sin x by x? Nabil Khan, what is the value of this limit x tends to 0 sin x by x?
Sin 0.
No, this is 1. Okay, we have already done this formula. So please, all of you learn the formulas of limit, because in continuity and differentiability, there is a use of limits in each and every question. So if you do not understood limit or you do not learn the formula, then it will not be possible for you to solve the questions of continuity and differentiability. Next, again, Nabil Khan, what is the value of this limit x tends to 0 cos x?
1.
Again, 1. Very good. So 1 plus 1 is equal to 2. So here we can see that limit x tends to 0, limit x tends to 0, fx is equal to f0 is equal to 2. Hence, fx is continuous. Hence, fx is continuous at x is equal to 0. Okay. So I hope this is clear to everyone. So please note down this, confirm, and then raise your hands. Then we will start the next question. Dushan, I just said that please note down this, okay? And let me know once it is done so that we can start the next question. Okay, Atif and Noma. Darshan, Nabil Khan and Nabil Ahmed. Please let me know if it is done. Okay, Darshan, very good. So, okay, Nabil. So I hope everyone has done this. Now we
Yes,
will
sir.
start the next question. Okay. Okay. Next is this question. Okay, in all these questions, there is a use of limits. Now, everyone know the formula? Examine the function fx given by this for continuity at t is equal to 1 by 2. So please check this and let me know that this function is continuous or not. And one more thing, if you will get a time, then please revise the questions which you have done in class 11 in the chapter limits. Okay, because we have discussed the method, but we do not have so much time to do the questions of limit of class 11. So please take out your old books and try to solve some questions. Now please do this and let me know if anyone have a doubt here. Nabil, is it done? Nabil Ahmed? Okay. Okay, Atif, very good. Atif, what the value of limit you are getting?
Sir, one.
One. Very good. Very good, Atif. It is correct. So, Nabil Ahmed, Darshan, Nabil Khan, Noma, please confirm me if you get the answer, or if you have any doubt, please let me know. Please let me know if anyone have a doubt here. Okay, Atif has completed this. Nabil Ahmed, Darshan, Nabil Khan, Noma. Any doubt? Do you need help here? Yes. I will solve this. All of you, please check here. I know you are facing the difficulty. It is continuous. Okay, great. Great, Darshan. Now, first of all, we need to check the limit x tends to pi by 2 fx. So, Darshan, will you please tell me that which function we will choose to calculate the limit? Darshan, which function we will choose to calculate the limit? First one, very good, Darshan. So, limit x tends to pi by 2. I'm writing x. T tends to pi by 2, t tends to pi by 2. Okay, cos t by pi by 2 minus t. Why do we choose the first function? The same reason, Nabil. T tends to pi by 2, t is not equal to pi by 2. Okay, as we have discussed in the previous question, t is approaching to pi by 2. T is going towards to pi by 2. T is not equal to pi by 2. Okay. Nabil, is it fine? Okay. Now, Darshan, can you tell me how can we solve this? Because if we will directly put the limit, we will get a 0 by 0. So, Darshan, what is the method? Darshan, can you tell me what is the method to solve this limit? No? Which formula, Darshan? Good. Darshan, if you wish, you can unmute yourself, okay? And you can tell me which formula we will use here. The mic is not working. Okay, no issue. Atif, can you tell me which formula we will use here to solve this limit? Atif, can you tell me which formula we will use here? Atif. Okay, please check here. So we will start with the direct method. If we are directly we are putting this limit, we are getting 0/0. So we will check second method. Factorization not valid for this question. Rationalization not valid for this question. And we do not have a standard formula for this. Okay, there is, but we will try to ignore. But whatever the formulas I told you, that do not suit for this question. So in such a type of question where you do not have any clue, try this thing. Put t is equal to pi/2 plus h. I am not finding the LHL or RHL. I'm not finding the LHL or RHL. Okay, this is one more method which sometimes suits to the question. So here we will put t is equal to pi/2 plus h. Now please check here what we will get. Cos, in place of t, we will put pi/2 plus h. Okay, in the denominator we have pi/2 minus, in place of t, we will put pi/2 plus h. And what is the limit? Limit, earlier we have the variable t, now we have a variable h. That's why we will write h. What the limit of h will become, please check here. You have this one, t is equal to pi/2 when t tends to pi/2. If t will approach to pi/2, you have this, t is equal to pi/2 plus h. If t is approaching to pi/2, if in place of this t you will put pi/2, then definitely it will get cancelled out. H will comes to 0. So when t approaches to pi/2, h approaches to 0. Okay. So here we have put in place of t pi/2 plus h. Now you need to put h tends to 0. Okay. Okay, but please check this, that if the t is approaching to some value, h is approaching to what? Okay. Now here we get a h tends to 0. Now, Nabil Ahmed, can you tell me what is cos pi/2 plus h? Nabil Ahmed, can you tell me if you're using cos pi/2 plus h, what will be the answer? Sin h. No, not correct. Atif, what is cos pi/2 plus h? Atif, Darshan, what is cos pi/2 plus h? Yeah, Darshan, I'm saying what is cos pi/2 plus h? This one, this one. What is this? Cos pi/2 plus h? Noma, very good. You are correct. Darshan, no, it is not correct. It is minus sin h. Very good, Noma. It is minus sin h. Okay. Because pi/2 plus h lie in the second quadrant. In second quadrant, cos is negative. That's why minus sin h plus minus sin h. Okay. Now, if you will check the denominator, then in the denominator, okay, Darshan, no issue. Then it's fine. Nabil Ahmed, I will answer your query. Just give me a minute. Pi/2 minus h. Okay, we have just opened the bracket. Pi/2 will get cancelled out. So here we will get limit h tends to 0. Here we have a minus sin h by minus h. Minus minus cancel out. Here we get what? Limit h tends to 0 sin h by h. So this will give us a 1. Okay. So I hope this is clear to everyone that limit we are getting 1. Now, Nabil, I will answer your query. Let me complete this question. Now we will find out the f pi/2. So here we can say that t is equal to pi/2. This is 1. So f pi/2 is equal to 1. So we can say that limit x tends to pi/2 fx is equal to f pi/2, and this is equal to 1. Hence the function fx is continuous at x is equal to pi by 2. Okay. So all of you, please note down this. Let me know. Why do we have take h tends to 0? Okay. So Nabil, please check here. We have t is equal to pi by 2 plus h. So when t approaches to pi by 2, put in this equation. Nabil, please check this equation. T is equal to pi by 2 plus h. If t approaches to pi by 2, suppose this t become equal to pi by 2, then what will happen? In place of t, we can put pi by 2. We get a 0 here. So 0 is equal to h. But t is not equal to pi by 2. It is approaching to pi by 2. So when t will go close to pi by 2, then h will go close to 0. If t will become equal to pi by 2, h become equal to 0. Okay, but t is approaching to pi by 2. That's why h is approaching to 0. Okay, Nabil, is it clear? Okay, great. So all of you, please note down this, okay, and confirm me so that I can change the slide. And if anyone have a doubt, then please let me know. And I request to all of you, if you will get the time, then please try to solve some questions from the 11th limits chapter. Okay. So please raise your hand, whoever completed this, so that I can change the slide. Okay, Nabil, very good. Okay, Noma, good. Atif, Darshan, Nabil Khan, please confirm if it is done. Okay, Atif. Okay, Darshan. Nabil Khan, I guess you have also done this. Okay. I'm going to change the
Yes.
slide. Okay, okay, great. Please note down this, raise your hand, then we will start the next question. Okay, Nabil, very good. Atif, Darshan, Nabil Khan, Noma, is it done? Shall we start next? Okay, Atif, good. Okay, Noma, good. Okay, I guess all of you have done this. I'm going to start next question. If anyone has left, please let me know. Okay, so this is a very, very good question. All of you, please try this and tell me the answer. Discuss the continuity of the function fx at x is equal to 1 by 2. So at x is equal to 1 by 2, please check that the function is continuous or not. Okay. If anyone have a doubt, then please let me. Please check here. Okay. Please complete. Okay, Atif, so the function is discontinuous. Okay. What's the reason, Atif?
Yes, sir. I checked the first we check f of 1/2. I got the values 1. Then I checked the left-hand limit and I got the values 1/2. It's not equals to so continuous.
Very good. So that means limit does not exist. So what the left-hand limit you get?
Yes, sir. 1/2.
1/2 or 0? LHL. This is correct that limit does not exist, but please again try to check it. LHL should be 0. And what is RHL you're getting, Atif? Atif, after this, please tell me what the RHL you're getting. Okay. Anyone else has find this? Anyone else has calculated the limit? Nabil Ahmed, Darshan, Nabil Khan, Noma. Did you get the answer? Please check here. Here we have an inequality. I already told you that in case of inequality, please use the LHL and RHL concept. So anyone else get the answer? If anyone have a doubt, then please let me know. Okay, so when we were doing the limits, I already told you that in two cases, you always need to use the LHL and RHL concept. First is when you have an inequality in the question. And the second is when you have a modulus in the question. Okay, because in class 11th, you have already defined the modulus. We will again check whenever we get a question of mod here. So first of all, we will find out f1/2. So please check here. At x is equal to 1/2, we have the value 1. So f1/2 is 1. Now we need to calculate the limit. Limit x tends to 1/2 fx. We have to calculate this one. So as we can see, we have an inequality. That's why we will calculate the LHL and RHL. Okay. As we have already discussed, we need to calculate LHL at x is equal to 1/2. Now who can tell me? Noma. Noma, can you tell me for LHL which function we will choose? First, second, or third?
First.
Very good. First function. Good. So we will write limit x tends to 1/2 minus, okay, fx. So as Noma already told us that we need to use the first function here, 1/2 minus, what is the first function? 1/2 minus x. After this, again, the same thing, put x is equal to 1 by 2 minus h. Okay. And in the bracket, always write when x approaches to 1 by 2 minus h approaches to 0. Again, LHL, RHL, you will always get h tends to 0. In the previous method, you need to always check this. So here what you will get, limit h tends to 0. This is 1 by 2 minus, in place of x, you will put 1 by 2 minus h. This is equal, then open this bracket. So you will get here limit h tends to 0, 1 by 2 minus 1 by 2 plus h. Okay, this will get cancelled out. So you will get what? Limit h tends to 0, h. Now put this limit. So you will get a 0. Okay, Atif. So answer should be 0. So all of you, please note down this. Raise your hands so that we can find the origin. Nabil Ahmed, did you get the answer? Okay, great. So Nabil, what is origin here?
RHL, I didn't get so. RHL,
RHL is?
RHL, I'm not getting so.
You are not getting. Okay. So all of you, please raise your hands. Once you note down this, then we will calculate RHL. Okay, Noma, very good. Okay, Atif, you are back. Atif, what is RHL you are getting here?
Sorry, sir.
What's the value of RHL you are getting?
So I did not calculate the RHL.
Okay. Always, okay, because you will get the marks of the steps also. Always calculate LHL and RHL. Darshan, is it done? Okay, great. Nabil Khan, is it done? Shall we start next? Okay, great. Okay, so now we will calculate RHL. RHL at x is equal to 1 by 2. Okay, so limit x tends to 1 by 2 plus.
RHL is 1 by 2.
RHL is 2 by 2. That's correct. That is one. Okay, who can tell me? Darshan. Darshan, can you tell me which function we will choose for the RHL? Darshan, can you tell me which function we will choose for the RHL? Darshan, if you can hear me, then please reply. Okay, Nabil, so I'm liking, okay, Darshan. Nabil Khan, can you tell me which function we will choose for the RHL? First one, no, that's not correct. You can then tell me Noma for RHL, which function we will choose? Third one, very good. Nabil Khan, please check here. 1 by 2 plus RHL means that you are approaching to 1 by 2, but from the right side. So if you are approaching from the right side, then that value should be greater than 1 by 2. Very close to 1 by 2, but greater than 1 by 2. If you will check here you have the value less than 1 by 2. If you'll check here the value is greater than 1 by 2. So if the value is greater than 1 by 2, then that means we will take this value, 3 by 2 minus x. So limit x tends to 1 by 2 plus 3 by 2 minus x. Okay. Now the same thing, put x is equal to 1 by 2 plus h. So what you will get here, again in the bracket, write when x tends to 1 by 2 plus h tends to 0. So what we get here, limit h tends to 0, 3 by 2 minus 1 by 2 plus h. open this bracket. Okay, limit uh, h tends to 0, 3 by 2 minus 1 by 2 minus h. Put this limit, so we will get a 3 by 2 minus 1 by 2. So this will give us 2 by 2, which will give us 1. Okay, so we can say limit x tends to 1 by 2 minus fx is not equal to limit x tends to 1 by 2 plus fx. Hence, limit do not exist. Hence, limit x tends to 1 by 2 fx does not exist. Does not exist. Hence, fx is not continuous, not continuous at x is equal to 1 by 2. Okay, so all of you, please note down this and raise your hand if it is clear to you. Okay, we have done many questions now. Rest of the questions you can do on your own. Okay, so please note down this and let me know if anyone have a doubt here. Okay, Darshan, you have again joined. So Darshan, is it clear? Okay, Nabil, very good. Darshan, is it clear? Okay, great. Okay, so all of you, please raise your hand once you will complete it. Okay, Atif, good. Nabil Ahmed has already done. Noma and Nabil Khan, please confirm me if it is done. Nabil Khan and Noma. Okay, Noma, good. Okay, Nabil, very, very good. Then we will check the next question. Yes, discuss the continuity of this function fx given by at x is equal to 2. Okay, so all of you please try this and let me know the answer. Okay, Atif, very good. So Atif, what is the reason?
Yes, sir. I got f of 2 as 4. The left hand limit is 4, but the right hand limit is 0. So it's not equal. So it's not very.
Very good, very good. Limit does not exist. That's why it is not continuous. Very good. So Nabil Khan, Noma, is it done?
No, sir, I meant the RHL.
Okay, okay, please calculate it. And if anyone is facing problem here, then please let me know. Very, very good, Noma. Noma, what is the value of LHL?
LHL is equal to 0 and RHL is 4.
Very good. Limit does not exist. Great. Nabil Khan, is it done?
Done, sir.
Okay, Nabil. Nabil, what is LHL? Nabil Ahmed, what is LHL?
LHL is 0, RHL is 4.
Very good. Nabil Khan, is it done?
Sir, eligibles.
What is LHL?
0 and RHL
RHL is
4.
very, very good. Very good. That's correct. So you will write limit does not exist and the function is not continuous.
Sir, in that question, how will we find f of x, sir?
Very, very good question. So anyone can answer this question. How can we find F2? Anyone can tell me?
So in the equation we can see that x is equal to 2. The f of x will be 2 plus x. So we can substitute.
Very, very good. Very good, Atif. So Nabil, please check here. Here this is x is greater than or equal to 2. Okay, so greater than as well as equal to. So for this x is equal to 2, we will choose the same function. This one, 2 plus x. Okay.
Yes, sir.
Okay, great. This is
So can you please tell once again?
okay, okay. Noma, please check here. If we need to calculate the value of f2, then what function we will choose? Please check here. Here it is x is greater than equal to. So if we need the value at x is equal to 2, we will choose the function fx is equal to 2 plus x.
Okay, sir.
Okay. This is a very simple question. This you can do on your own. So this is a homework. Please note down this. This question is a homework. Okay, and all of you, please raise your hands once it is done. You need to solve this in homework. Please just note down the question. Okay, Nabil, good. Atif, Nabil Khan, and Noma, please raise your hands if you have noted down this. Okay, Noma, very good. Atif and Nabil Khan, is it? Okay, good. Nabil Khan, is it done?
Yes, sir.
Okay, okay, great. Next, we will check. Yes, this is a very, very good question because here we have a modulus. So I will solve this. Okay. So we have this 2x minus mod x is continuous at x is equal to 0. So first of all, we need to define the mod x. Mod x modulus x is a very important function because in many chapters we will use this modulus. Okay. In integration, we will have this. In application of integral, in differential equations, we have a use of this modulus function. Okay, so you have already done this modulus function last year in relational function. So anyone can explain to me, anyone can tell me that what is actually a modulus function?
It is total, whatever is inside modulus function is positive. No matter
Very
what it is, no matter whether it is negative or positive, once you apply mod, the net answer will be positive.
Very good, Nabil Ahmed. This is correct. If we will put any number inside the modulus that is negative or positive, we will get a positive answer. That's correct. can you explain me much more about it? What is the graph of this, or how can you define this modulus function? Anyone else? Noma? Noma, we have done this modulus function last year. Can you explain this to me?
Graph will have a mirror. Graph will form like a mirror on either sides of the axis.
Very, very good. Like this. This is a graph. That's also correct. Uh, Anyone can explain more?
Like if you want to expand mod function, we take two
Yes.
values. One is positive, one is negative.
Yes. So mod x. Yeah, this value I need, Nabil. Very good. So Nabil, can you tell me what we will write here?
For
What?
x is greater than or equal to 0, we will write 2x minus x.
Okay, okay. I'm just right now. I'm just doing this modulus. Okay. This question we will see later on.
Yes, sir.
So
So
x
just
is
x, and if x is less than 0, you write it as minus x.
very, very good, Nabil. This is correct. Very good. So all of you, please check here. We have a modulus function. What is actually a modulus function? First, we will discuss this one. So what is modulus? If you will put any value inside this modulus, it will come this, you will always get a positive value. If you will put a negative value, you will get a positive. If you are putting a positive value, you will get a positive value. So how modulus work? How it give you positive answer always? So there must be some formula. Okay, so what is the formula here? So modulus always check if you are putting a value which is less than 0. Okay, if you're putting a value inside the mod, for example, if you're putting here -2. So modulus, first of all, analyze that what value you're putting here. If you're putting less than 0, then what modulus do? Modulus will take the value, modulus will take the value minus x. If you're putting a value, there's no need to note down this, okay? At the end, I will give you the summary. If you're putting a value less than 0, then modulus will take the value minus x. So what will happen? You will get here minus x. Now, if you're putting, suppose x is equal to -2, this is a negative value. So what modulus do? Modulus will ask you to take the value as minus x. So what is minus x? Minus, in place of x, put this value. So -2, you get a 2. So please check here, you're getting a positive answer. Okay, so we have only two options. Either we will put a positive value or a negative value. If you're putting a negative value, then modulus will ask us to use -x. We will write this negative. In place of this x, we will write -2, so we get a positive answer. If you are putting a value which is greater than or equal to 0, that means you are putting a positive value, then what modulus do? Modulus will tell you to take the value as x. For example, if you're putting a 3, this is positive. So what this value you will take? 3. Okay. So if you're putting a negative value, then you have to take -x. If you're putting a positive value, then you have to take x. Okay. In this way, we define a mod. So what is actually a mod? We have only two options. Either we can put a positive value greater than or equal to 0, or we can put a negative value less than 0. If you're putting a positive, then take modulus value as x. If you're putting a negative value, take the value as -x. Okay, so please raise your hand if this concept is clear to you. This is a very important concept. We will use this in integration. We will use this in application of integral, even in differential equation. So if anyone have a doubt, then please let me know. And if it is clear, then please raise your hand. Atif, Nabil. Okay, Noma, good. Atif, Nabil Khan, please raise your hand if it is clear. Good, Atif. Nabil Khan, very good. So just note down this, that what is a modulus? First of all, we will define modulus. Modulus of x is equal to what? X when x is greater than or equal to 0, minus x when x is less than 0. Okay. Okay, so we have defined this model. Now we will check our question. Question is what? Fx is equal to 2x minus mod x. Okay, so we have this function fx is equal to 2x minus mod x. So what we can write here, as we have a modulus here, That's why we will define this modulus. Just focus on this part. If we will choose x is greater than equal to 0, then who can tell me? Nabil Khan. Nabil Khan, can you tell me if you are taking x is greater than 0, then in place of this mod, what we have to write? Nabil Khan, in place of this modulus, what we have to write if we are putting x is greater than equal to 0?
2.
Only in place of this x, only in place of this. Forgot about this part. Just focus on this modulus. What you will write in place of this modulus x if you are taking x is greater than 0? Good, Nabil Ahmed. Nabil Khan,
No ideas.
no idea, no issue. Noma, in place of this modulus x, what you will write?
X.
X. So please now check the complete question. You have 2x, okay, minus, okay. In place of this modulus, what you will write because of this? 2x minus x. And what is 2x minus x? You will get a x. So that means if you have a value x is greater than equal to 0, then we will use x. X is less than 0. Who can tell me? Atif. Atif. So we have 2x here. We have minus here. In place of this mod, Atif, what we can write?
Minus x.
Minus x. Very good. So open this bracket. 2x plus x. 2x plus x give you 3x. So when x is less than 0, you will get a 3x. Okay. When x is greater than, okay, Atif, you have done this. What was the question? Very good. This is correct. Okay, Nabil Khan. Now is it clear?
Yes, sir, it's clear.
So, okay, very good. So what the final result we have got? So we will write like this. We have a value x when x is greater than equal to 0. We have a value 3x when x is less than 0. Okay. So all of you, now this become a very simple question. Please check the continuity of this and confirm with answer. Okay, so Atif has already done this. Nabil Ahmed, Nabil Khan, Noma, please confirm if it is done. You need to check the continuity. Okay, please use the LHL and RHL method. Okay, Noma, very good. Nabil Ahmed and Nabil Khan, please confirm me if it is done. Why it is discontinuous, Nabil? Nabil,
LHL is 0, RHL is 2.
RHL is also 0. Please check here. We have a X here. Final result, we are getting X. So if you will
Yes,
find,
yes, yes, yes.
okay. Nabil Khan, is it done? Very good. So, okay. So, Nabil Ahmed, shall we start next? Is it done now?
Yes, sir.
Okay, great. This is a very good question. Okay, but this is you have to do in homework. I will check this homework tomorrow. Please note down this and confirm me. We will discuss, this you need to do in homework and I will check it. Okay. Please raise your hands once you note down this so that we can start the next. Same function you will get in application of integral. Okay, Nabil, very good. Okay, Noma, good. Atif and
Okay,
Nabil.
sir.
Okay, good. Atif, is it done?
Yes, sir.
Okay, great. Okay, so today I have given you two questions. So please solve these two. Next, let me check how much time we have. Okay, so hardly we have 10 minutes. We will do the rest of the questions tomorrow. Your homework is do these two questions, revise the same topic, and please complete the rest of the assignments of differentiation. Okay, it is a very important, and because you need the same concept in application of derivative, integration, differential equation. Most of you do not have the doubt because you have not completed the question. Whenever you will start doing the assignments, you will face some doubts because there are some tough questions in the assignment. So please, I've just given you two questions from this topic. So please complete the assignment and tomorrow you have a test of complete differentiation. Okay, so whoever have a doubt, then they can